Hello students, this video is about perpendicular bisectors of triangles. In this video we're going to be talking about these specific lines that you can draw inside of a triangle that are perpendicular bisectors, and it's right there in the name. They're perpendicular to a base and they bisect that base. Alright, moving on to the target, we're going to be doing two specific things today. One of the things we're going to be doing is applying properties of perpendicular bisectors to solve for unknowns. Essentially, we're looking at a situation, we're looking at a diagram, and we're using the idea that we're looking at perpendicular bisectors to write an equation and to solve for a variable. The second thing we're going to be doing is finding the equation of a perpendicular bisector for a given triangle. Keep in mind that the equation of a line is very straightforward. It's just y equals mx plus b. In this do now, it's very straightforward. It's just asking you to define the two vocabulary terms below because we're talking about perpendicular bisectors today, and both of these words mean something very specific in geometry. So pause the video and try this one out and come back to see if you got it right. Alright, our first word that we're defining is perpendicular. Keep in mind that perpendicular means lines that intersect and form right angles. Another way to define perpendicular is that they are lines that have negative reciprocal slopes. So the two slopes that you are seeing here are a slope of 0 and a slope of undefined, respectively. However, any two lines that have negative reciprocal slopes are going to be called perpendicular. Here's an example of negative reciprocal slopes. This 3 over 4 and this negative 4 over 3, we call these negative reciprocals. And notice there's no equal sign between them because they're not equal, right? These two slopes are negative reciprocals, which means I take the original slope, I flip it upside down, that's the reciprocal part, and I change its sign from positive to negative, that's the negative part. All right, bisector is another word, and let's take a look at the definition of bisector. A bisector's job is to divide or split a figure in half, and it creates two parts that are half of the original figure. So in this case, we're looking at a line segment, this red line segment, and this point splits that line segment in half, and it creates two parts, this line segment here and this line segment here, that are both half of the original figure. So this point is called a segment bisector. Of course, normally we call this thing not a segment bisector, we call it a midpoint, but it could also be known as a segment bisector because that's what it does, it bisects a segment. Similarly, over here we have an angle bisector. We call this black line an angle bisector because it splits this red angle into two equal parts. You can see that they both have this one arc, that means they're equal to each other. So those are two equal parts that are half of the original figure. And now if this little angle here is, let's say, 15 degrees, this would also be 15 degrees, and the whole entire angle would be 30. If this line, this little line segment here was 10 inches and this was 10 inches, the entire line segment would be 20 inches, right? All right, so let's take a look at what a perpendicular bisector, putting both of these together, perpendicular and bisector, what that looks like in terms of a triangle. Let's try to fill in these blanks. All right, it says here that a perpendicular bisector of a triangle is a line segment that passes through the midpoint and is perpendicular to the line segment. Let's take a look at these two examples. In both of these examples, you should see one of the classic hallmarks of a perpendicular bisector, that perpendicular bisector does not always pass through a vertex. So this line that I'm going to highlight in yellow, this line we call a perpendicular bisector. The reason we call it a perpendicular bisector is because it passes through this midpoint, right? And it is also perpendicular to that line segment. In other words, these two lines form a right angle, like so. So we call this line, the line that I highlighted in yellow, a perpendicular bisector. Similarly, this line here is a perpendicular bisector because it passes through the midpoint of this triangle, the midpoint of this line segment, the side of the triangle, and it has two sides that are congruent to each other. So it passes through a midpoint, and it is, and in addition, it is also perpendicular to that side. So those two things have to be present in order for it to be a perpendicular bisector. The good thing is, once you know that a line segment is a perpendicular bisector, you know those two things automatically. You know that we're looking at a midpoint, and you know that it's going to be perpendicular to the line segment. In other words, it's going to have right angles. Let's take a look at model problem number 1. In this diagram, DF is a perpendicular bisector, so it tells us right there what it is. Now we can apply these two pieces of information that we know, the midpoint and perpendicular information. If the measure of EC is 30 inches and the measure of CD is 17 inches, what's the measure of DF? Pause the video and try this one out, and then come back to see if you got it right. All right, here's the first two pieces of information that we know, 17 inches for CD, 30 inches for EC. But what we're looking for is a measure of DF. Notice that DF is this line here. This is a perpendicular bisector, but we don't know its measure. Well, let's try to figure out some things that we do know. First, it's a perpendicular bisector. This part of it, bisector, tells us that it intersects this line, line CE, at its midpoint. And it even has those lines drawn in there. It says that this measurement is equal to this measurement. That means if this whole entire side, CE, is 30 inches, that means that each of these individual line segments that are created by that midpoint are half of that. So 30 divided by 2, that's equal to 15. All right, you might be saying to yourself, well, that's not super important because we're not looking for FC or CF, we're looking for FD. Well, now we have this side of the triangle, and we also have this side of the triangle. Well, it turns out that I only need one more side to make this a right triangle. How do I know it's a right triangle? Because it's a perpendicular bisector. Since it's perpendicular, that means these two lines intersect at a right angle. So now I have two different sides of a right triangle, and I'm looking for a third. That's right, we're looking for our old pal Pythagorean theorem. Let's see how this worked out. I know that a squared plus b squared is equal to c squared, and these two values a and b are going to be the legs of the triangle, and c is going to be the hypotenuse, so that's the 17 inches, right? So we put that c as 17 inches, and we're choosing that 15 inches is going to go in for b. It doesn't really matter where it goes here. It could be a or it could be b. So 15 squared is 225, 17 squared is 289. Good idea to memorize those timetables to save a little time on your calculator. And then subtract 225 from both sides and we get 64. I know that df squared is equal to 64, which means I got to square root both sides in order to get my correct answer. So I square root both sides and I get df on the left-hand side, and 64 square rooted is 8. So here's my answer. Now I'm able to say that df is equal to 8 inches. We're using inches because all of the other measurements here are inches. Great. The check for understanding number 1, we're going to be doing in class, but keep in mind it's going to be the same kind of idea. You're going to set up a scenario using values that you know and using the ideas based on what they tell you about a perpendicular bisector in order to solve for an unknown. That was the first part of the learning target. Moving on to model problem number 2, which is equations of perpendicular bisectors. This is no surprise because we did equations of every other type of line segment that's inside of a triangle. The equation of a line, I wish I could make it a little bit more complicated for you folks, but all it is finding the slope and finding the y-intercept. That's the whole trick. So once you find the slope and the y-intercept, you're good to go. I guess the only challenging part is figuring out what points to use in order to make this triangle, in order to find that slope and y-intercept. So here's what we need to do. So how do the equations of perpendicular bisectors differ than the equations of other things like medians and altitudes? Well, I know that perpendicular bisectors have two things, or two characteristics. Perpendicular means they are at right angles, and bisectors means they pass through a midpoint. So let's deal with the first thing first, perpendicular. We need to find a perpendicular line. In this case, for triangle ABC, we need to find a perpendicular line to side BC. So the first thing we're going to do is looking at side BC from here to here, we're going to try to find its slope. That's this procedure here. Y2 minus y1 over x2 minus x1. There's our slope formula, and we solve that to get 2. So that's the slope of BC, and you can see up 2 over 1, up 2 over 1, etc. So that's the slope of 2. What we need, however, is the perpendicular bisector's slope, and we know that the perpendicular bisector is just that. It's perpendicular to BC. So in order to write the slope of the perpendicular bisector, we need to find its negative reciprocal. Just like we talked about at the beginning of the video, we start from 2 over 1, which is 2, and then we're going to flip that around, take it to 1 over 2, and then change its sign from positive to negative. So our new slope for our perpendicular bisector is 1/2. There's the slope. Then the next thing we need to do is find the y-intercept. In order to find the y-intercept, we need the slope, and we also need one point that the line passes through. Well, we don't have any point that the line necessarily has to pass through. With medians, we were able to use this point, the vertex, but the perpendicular bisector doesn't necessarily pass through a vertex. So what we need to do is use the other part of perpendicular bisector, which is, of course, bisectors. A bisector passes through the midpoint of a segment, which means I'm looking at BC, I need to find its midpoint. That's what we did here. This is the midpoint formula, capital M for midpoint, x1 plus x2 over 2, y1 plus y2 over 2, we get 3 comma negative 1. And if I plot that out, it's pretty easy to see that that is definitely the midpoint of this line. It's right directly in the middle. Okay, so we have the slope. There's m. This is not b, though. This is just a point that goes that is on the perpendicular bisector. So we'll call this x comma y. So here's what we can do with that x comma y now. We can take that and substitute it into the equation, knowing that the slope is supposed to be negative 1/2, and this x and y are supposed to be 3 and negative 1, to actually write out the equation of the line. So we substitute in negative 1 for y, 3 for x, and negative 1/2 for the slope. Now the only unknown we have is b, so we solve for b. Long story short, we get b is equal to 0.5, so we know that the equation is just putting those two parts together. The equation is going to be y equals negative 1/2 x plus 0.5, right? If I were to graph the perpendicular bisector, it's going to look like a perpendicular bisector. In other words, it's going to be perpendicular to the line that we're talking about, and it's also going to bisect that line. This line, BC, is perpendicular to the line that I just drew. It's got a right angle there, and that line that I just drew goes through the midpoint of BC. There we go. We drew the equation, or we graphed the equation of a perpendicular bisector, and we identified that equation as well. I don't want to shock you, but the check for understanding number 2 is the exact same process. We're just going to be graphing the triangle as well. All right, that was the video on perpendicular bisectors. Good luck studying.